Hi students, this is Mrs. Luther, ready to do the first part of section 2.7. So today we're going to talk about flowchart proofs. Now that you've got a good taste of two-column proofs, we're going to talk about a different type of proof. So by the end of today's lesson, you should be able to write a flowchart proof and translate a flowchart proof into a two-column proof. Why don't you go ahead and pause, do the warm-up to complete each sentence. If the measures of two angles are what? Then they are congruent. So if the measures are equal, then the angles are congruent. Second one, if two angles form a what? Then they are supplementary. So we have the linear pair theorem that says if two angles form a linear pair, then they are supplementary. And lastly, if two angles are complementary to the same angle, the two angles are congruent. We just proved that theorem the other day in lesson 2.6.2. So these were three definitions slash theorems that you will be using in proofs from here on out. Okay, flowchart proofs. So a second style of proof that we're going to learn, which uses boxes and arrows to show the structure of the proof, is called a flowchart proof. The steps in a flowchart proof move from left to right or from top to bottom. So always in this direction or this direction, never the other way. And they use arrows connecting boxes. The justification for each step is written below. So what you would have, it would look like the statement would be in here, and the reason would be below. Now I know it says boxes and I kind of circled it. It's not really very specific. You can do circles or boxes, whatever is easiest for you. Okay. So let's take a look at the common segments theorem. Remember, once we introduce a theorem, we can use it in any proof that we want because we're going to prove it before we move on. So the common segments theorem says, if we have collinear points, A, B, C, and D. So remember, collinear means on the same line. So you can see that points A, B, C, and D are all on the same line. And if they're arranged as shown, so in order, okay, then segment AB, if segment AB is congruent to segment CD, then AC, segment AC, will be congruent to segment BD. So the hypothesis is that if AB is congruent to CD, the conclusion is then AC will also be congruent to BD. Let's take a look at the flowchart proof for this. So we're going to use this given flowchart proof to write a two-column proof of the common segments theorem. So it says given, segment AB is congruent to segment CD. So take a look here. AB is congruent to CD. They even drew that on our picture for us already. We want to prove the conclusion here. So here's our flowchart proof. It says here the first step, segment AB is congruent to segment CD, and you can see the reason, excuse me, the reason here is written right underneath. Now you'll see they take this arrow and they go down here. So this is the if this guy, if this is true, then this has to be true. So if segment AB is congruent to segment CD, then the length of AB is equal to the length of CD. How do we know? Definition of congruent segments. So if we look at our two-column proof, step one is our first box. The statement is segment AB is congruent to segment CD, and the reason is given. Step two, see the arrow comes down here, so that's going to be our step two, is that the length of AB is equal to the length of CD. How do we know? Definition of congruent segments. And remember, we're not going to say it that way anymore. We're going to instead say congruent means equal measures. That's how we're going to say it. So now you'll notice this arrow goes to this guy, but it also has an arrow from here, which means that this one is going to be our next step. Because clearly we can't have this box until we have this one. That's what the arrow means. So you'll notice our next one says that the length of BC is equal to the length of BC. Well, that's just the reflexive property of equality. Right? Something's always equal to itself. Now, if this is true and if this is true, then this is true. So we needed both of these pieces of information to be able to do this box. So if this is true and this is true, then look at, I can add BC to both sides of the equation, AB plus BC and CD plus BC. Add the same thing to both sides. That's just the addition property of equality. Next, the arrow goes this way, but it also comes down from this way, which means that this is our next step. So the segment addition postulate tells us that AB plus BC has to equal the whole. So part plus part, part plus part equals the whole. But they also said that this part plus this part equals the whole. So BC plus CD equals BD. Looks like I kind of went a little too far on that one. There we go. Okay, so that's our next step in our proof here, and that's the segment addition postulate, part plus part equals whole. Now this is our next step, and that's the tricky one. So if this is true and this is true, notice that AB plus BC is also represented up here. Right? So since it's represented in both places, we can replace AB plus BC with AC, and we can replace BC plus CD with BD. See how they color-coded it there for you to see how it happened? So we replaced, so that would be substitution. And then finally, since the measures are equal, then the segments are congruent. And we're not going to say definition of congruent anymore. We're going to say equal measures means they're congruent. All right, why don't you go ahead and answer the questions in your Google form. I'll see you shortly.